Hello all, and thank you for listening to Mr. Laxton's video on this Chapter 1 practice test. Alright, so hopefully this video will help you get a little bit more prepared for the test that is coming up soon. Alright, so here is me talking through these answers to see what we got. Alright, first one, name the properties that are shown. The first one there is 250 times 1 is equal to 250. Remember here, you cannot change your identity. So this is identity, and this is the property of multiplication. So if you want to just put a little multiplication there, that's fine. I get it. I get the deal. All right. The next one is 3 plus -3 gives me 0. All right. So this, remember how 3 and -3, those are the additive inverses of each other. So this is the inverse property of addition here. All right, this one, number 3, is kind of the most common one here. If I distribute that in there, it gives me 6x minus 24. That is the distributive property. Distributive property there. The number 4 is 8 plus 7 is equal to 7 plus 8. Remember there that it doesn't matter which way you add two things. The two things is commutative. So commutative. And the next one here, number 5, so this is commutative of addition, but number 5 is 3 things talking to each other. It doesn't matter which way those 3 things talk, is associative. So associative. Don't be afraid to abbreviate these if you want. That's okay. I get it. Don't abbreviate associative with the first 3 letters. That might look a little wrong. But anyways, so there we go. Identity, inverse, distributive, commutative, and associative. All right, so the next one, you have to mark all of the answers that apply to each number. So I like to go through, hey, we learned that every single one of these numbers is going to be real. So I like to just, hey, real, I'll give you a hint. Every single one of these numbers is going to be real. We're not going to look at not real numbers until chapter 7 or so. Okay, so now I'm just going to go down the line for number 6. Is -17, is that a natural number? So remember, natural numbers are my counting numbers, 1, 2, 3, 4, 5. That does not include negatives, so no, it is not a natural. Is it a whole number? Whole numbers are the counting numbers plus 0, so it's not that either. Is it an integer? Yes, it is an integer. -17 is a negative or positive whole number. Is it a rational number? Yes, it can be written as a fraction. Okay, -17 over 1 is a fraction, so it is a rational number. Okay, the square root of 11. All right, the square root of 11, not a natural number, not a whole number, not an integer. So now I have to look at, is it a rational number or an irrational number? So remember, rational numbers can be written as fractions. Irrational numbers cannot be written as fractions. So a way to kind of figure this out is to plug the square root of 11 in your calculator. And the square root of 11 in your calculator goes on and on, takes up your whole calculator, so it is an irrational number. All right, awesome. -3.8. Again, that's kind of a nice one because no, it's not a whole number. It's not a natural number. It's not an integer. All right, is it a rational number or an irrational number? 3.8, the decimal ends. So this ends. So that tells me that, hey, this is a rational number. Okay, 15, that's kind of a good one. That's going to be a lot of them because, yes, it is a natural number. That starts with the counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, goes all the way up to infinity. So, yes, it is a natural number. Yes, then is it a whole number? If it's a natural number, it's a whole number. All right. And 0. All right, integers. Yes, it is an integer. It is a positive or negative whole number. And it is a rational number. It can be written as a fraction. So this is a rational number as well. All right, so you got to have all those in order to get all the points. So you got to know how those guys work. All right, so if I flip up to the top right-hand spot here, we have to find out, we have to evaluate these guys. So we have to use PEMDAS. All right. So I have to use parentheses first, exponents, multiplication, division, and then adding, subtracting. So here I have to do inside my parentheses first. -3, I can't do anything with that, so I still have -3 squared. Minus, in the parentheses over here, 4 minus a negative 9. Remember, ding dong or cross slash, however you remember it here. 4 plus a positive 9 is 13. All right, and then here I have negative 3 squared is negative 3 times negative 3, which is positive 9 minus 13, which is negative 4. Okay, so negative 4 goes there. All right, now here for number 11, I got to do in my parentheses first. So I have 2 minus 3 first. So I have 12 plus 12, and then 2 minus 3 is negative 1. 12 plus, and then 12 times negative 1 is a negative 12. And you can notice here that, hey, now these guys are additive inverses of each other, so I'm going to get 0. 12 plus negative 12 is 0. All right, awesome. As we keep on going on here, number 12, you have to find out what these guys are when you actually plug them in. So now I have 5 times 3 squared plus 7 times 16 minus 13. Okay, got to do inside your parentheses. 3, I can't do anything with that. 16, can't do anything with that. My parentheses is gone. Exponents. So I have 5 times 9 plus 7 times 16 minus 13. Okay, 5 times 9 is 45. Oh, this is 45 plus 7 times 16. You can plug that in your calculator. That is 112 minus 13. So now I have to add and subtract straight across from left to right. So 45 plus 112, then minus 13. That is going to be 144. Alrighty, awesome. So now, hey, plug these guys in here. I'm going to have 5 times negative 7 minus a negative 4 here. Okay, that tricky part is minus the negative. Make sure you make those both into pluses. Ding dong, cross slash. Negative 35 plus 4, and negative 35 plus 4 is negative 31. Awesome. All right, so now solving. Hey, these are kind of some of my favorite ones here. Solve these equations, show all your work, and circle your answer. So here for my first one, to solve for x, I got to add 9. I got to add 9. I get 5x is equal to 25. And to get x all by itself, I got to divide by 5, so I get x equals 5. Okay, that's all my work. You're showing your work, you're good. All right, so number 17 is a little bit tricky because I got fractions here. But what I see is here I have a, so I'm going to subtract this a to this side because that makes 1a. And then I'm also, or I have plus 1/2 is equal to negative 2/5. All right, now I have to subtract this 1/2 to the other side. Okay, so now I have a is equal to negative 2/5 minus 1/2. Okay, and notice here, hey, I need common denominators to be able to add and subtract fractions. So do I have a common denominator? No, I have 5 and 2. What do I have to do to make them into common denominators though? I want to multiply this one by 2 and multiply this one by 5. So here I'm going to have what? Negative 4/10 minus 5/10. Negative 4 minus 5 is negative 9/10. Okay, so get a common denominator there. That one's a little bit trickier because they have fractions. I know we're not big fans of fractions, but get a common denominator. Go through what you can. All right, so apparently now I go to number 14, so I must have switched around some work there, but now I'm going to number 14. Number 14, I'm going to distribute these guys in here as much as I can. I like to make that plus and negative, so I make sure that I distribute that negative 5. Okay. Ooh, excuse me. So now I have 4x squared plus 4 times 3 is 12 plus negative 5 times 3x squared is negative 15x squared, and negative 5 times negative 9 is plus 45. Okay, so now I can just combine some like terms here. 4x and negative 15x is negative 11x squared, and 12 and 45 is going to be 57. All right, so that is my answer there. There's no solving, it's just an expression that we have to simplify. Okay, number 15, I like to make these all plus and negative so I know which terms are positive, which ones are negative. Combine some like terms here. So I have 6x and negative 1x squared is going to be 5x squared plus 5y and negative 11y makes negative 6y. All right, so 5x squared, if you have minus 6y, that's great too. Okay, so as I move on back onto the back page here, you need to solve and graph each inequality. Okay, so for the first one, you got to get all the x's on the same side. So I'm going to add the x over, and I'm going to subtract 1. Okay, so I have 12 is greater than 6x. If I divide by 6, I have 2 is greater than x. So be careful here. If I have a dot at 2, it is an open dot. Okay, if I have 1 over here and 3 over here, you have to make sure that this arrow goes this way, because remember, this is going to be the same thing as x is less than 2. All right, so anything that is less than 2 is to the left. That x needs to be on the left side in order for your arrow to point in the same directions. All right, number 19, we have an or. So remember now this is going to look like oars on a boat. So I should divide by that negative 3, divide by the negative 3. So I get w is less than negative 3. Or, got to add 4, so I have w is greater than or equal to 17. So I have greater than or equal to 17 and less than negative 3. So I have less than negative 3 is this way. Greater than is a closed dot. Greater than or equal to is that away. All right. Good. Number 20. Remember here how this one's an and. All right, if it's got two inequalities and one is an and, so we know that these are going to sandwich in together. So let's go through and see what we got here. I'm going to add 4 to all parts. Add 4, add 4, add 4. So negative 5 plus 4 is negative 1 is less than n is less than or equal to 13. All right, and that is my answer. All right, so here I have negative 1. Ooh, I keep hitting that same button. I have negative 1, and I have positive 13. Okay, closed dot above the 13 and an open dot above the 1, and then connect those guys with your and. Okay, awesome. The last one is section 1.7, which is absolute value inequalities and absolute value equations. Remember here, I got to get the absolute value all by itself first. So I add 3, I add 3. So now I have the absolute value of 4x minus 1 is greater than 13. But now you have to be sure that you break these into 2 equations. So my first equation is exactly what it looks like without the absolute value. 4x minus 1 is greater than 13. My second equation doesn't change anything in the absolute value. 4x minus 1 is now less than negative 13. So you got to make sure, oh, and excuse me, did I do that wrong? I did. This should be a minus 3. See, everybody makes mistakes. You got to catch yourself. I minus 3, so this should be a 7, and this should be a 7, and this should be a negative 7. All right, good catch, Mr. Laxton. All righty, so now those are 7s here, and I just go through and solve both of them. So I add 1, add 1, add 1, add 1. I kind of like to work all these same steps here. You don't have to. So I have 4x is greater than 8, and I have 4x is less than, what is this? Negative 7 plus 1 is negative 6. If I go by and divide by 4, divide by 4, divide by 4, divide by 4, I get x is greater than 2, and then I have x is less than negative 3 halves is what that simplifies to, negative 6 over 4. Okay, and again, like I said before in that video, you don't have to know exactly if that greater than means and or. You just have to kind of go through and graph this correctly for yourself. So I have x is greater than 2, so I know that my 2 is going to be to the right because this is a negative 3 halves. This is a 2. So x is greater than 2 goes this way, and then I have to, if this is going to be an or, it has to go this way. Okay, so x is less than negative 3 halves, which is going to point to the left there. Okay, awesome. Next one, the formula for the area of a triangle is that, solve for b. Okay, so here, remember, we multiply by 2 over 1 to get rid of the fraction, multiply by 2 over 1, so I have 2a is equal to h times b. And then remember here is that you can move these letters just like we move around numbers. So I take this h, and to get b all by itself, and I divide by h, divide by h. So now I have 2a over h is equal to b. All right, awesome. Very good, very good. All right, so I believe that in here you guys have a 1/5. Okay, Matt did not copy on mine very well, but I now need to solve for x. So I got to add 3 to both sides. So I get y plus 3 is equal to 1/5 x. And then now to get rid of that 1/5, you multiply by the reciprocal, which is 5 over 1. You have to make sure you do that to everything that's on the other side. So now these guys cancel each other out. So now I have 5 y plus 3 is equal to x. And you could leave it here, and that's okay. I'm just going to distribute it in. So I have 5y plus 15 is equal to x. All right. Awesome. All right, so 24 and 25 are the word problems. Got into a little bit of a tougher ones on here. So the sum of two numbers is 43. We talked about a lot of examples like these. The sum of two numbers, x plus y equals 43. The second number is, so let's say y is, remember is means equals, 3 more than, that means plus, 4 times the first number, so that's x. All right, so that's kind of the tough part, is getting those two kind of equations, and now the easy part is going through and actually plugging them in and solving here. All right, so here we go. To actually solve, I have to take the 3 plus 4x, and where do I plug that in for? You got it, I plug it in for my y, so now I get x plus 3 plus 4x is equal to 43. Okay, now I go through, combine like terms, get rid of this 3 to the other side. So now I have x and 4x makes 5x is equal to 40. We like that because we know, hey, 5 goes in there nicely, right? X is equal to 8. All right, and once I get x is equal to 8, now I can just bring it back into those original problems. 3 plus 4 times 8. So all I do is plug in 8 for my x right here. And this is 3 plus, what is this, 32. And 3 plus 32 is 35. Okay, so now you can kind of check yourself. Is the sum of these two numbers 43? Is 8 plus 35 43? Sure is. Is one number 3 more than 4 times the first? So if I take 8 times 4, that's 32, plus 3 is 35. So yes. All right. And my last one is this perimeter equation. All right. So remember here, perimeter, perimeter, perimeter. We always have 2w plus 2l. That's going to be every single time in a perimeter equation is now equal to 36, because that's what the perimeter is equal to. It says the width is equals 2 times the length increased by 3, so plus 3. All right, so now again, I have these two equations. I can just go through and plug them in and see what we got. So 2l plus 3. So now I'm going to plug that guy in for my w. So now I'm going to change colors here. I got 2 times. Instead of writing w, I'm going to write 2l plus 3, because that's equal to my w. Plus 2l is equal to 36. All right, awesome. So now here I distribute this guy in here. I get 4l plus 6 plus 2l is equal to 36. All right, now I go through, combine like terms, solve for this l here. I go minus the 6, minus the 6. So I go 6l is equal to 30. That's a 30, not 36. If I divide by 6, I get L is equal to 5. Awesome. Great, great, great. So now I go through, hey, I know that my L is 5. I have to find my length and my width of the rectangle, it says. So I can just go through and take my W equals equation. W equals 2L plus 3. And I can plug in my L. So I have 2 times 5 plus 3. All right, so I know my W is equal to 10 plus 3, which is equal to 13. And does it give me any units here? I don't think so. So my length is 5 and my width is 13. Awesome. So that does it. That wraps it up for this Chapter 1 practice test. This is the first test of the year, so make sure that you're ready for this guy. Make sure you know how to do these things. These things are going to be fundamental in doing the rest of Algebra 2. So come find me if you have any questions. Good luck on the test. Do your best, and we'll talk to you a little later.